Hello, meine Damen und Herren. I'm very happy to be with you today on this topic, important topic, and how our satellite data could be used, notably for disaster management and support, and also during construction for urban development. So, to plot the scene, the last past 20 years, the numbers of natural disasters are nearly doubled. At the same time, cities have been growing at a pace that have never been seen in the past. Would I say the climate change is driving more intense and frequent natural disaster, which increase a lot of costs. At the end, it is estimated at $100 billion per year, and the human toll is quite heavy because you have to displace people. You have also to make sure that you can relocate them in other place, so long-lasting consequences. And at the same time, the urban development is quite high. In 2050, 70% of the global population will live in a city, and often this is in high exposure zone, for example, seismic area, floodplains, or areas that could be predicted to a drought. With all this in mind, in fact, there is a link. The link is when you have a poor planning, in fact, you have risk for construction. And at the same time, if you have natural disaster, it impacts a lot the sustainable growth of cities. So this is where our constellation, Airbus constellation, is bringing value by bringing data, insights for people to create insights to have info for sustainable growth. When mentioning our constellation, in fact, we could divide it in two categories, the optical satellite sensors and the radar sensors. For the optical, we have a large breadth of range of resolution from 1.5 meters with spots, regional mapping, perfect when you need global overview, up to very high resolution with our Pleiades and Pleiades Neo satellites, down to 30 centimeter GSD, which is totally perfect when you need to ban activities for urban planning, etc. And even more with HD15, a post-processing option, allowing you to have fine features easily to distinguish. On the other side, you have also the radar sensors, Terrasa X, Tandem X, and PAS, working days and nights under cloud conditions, so perfect when you need also to have continuity. Thanks to INSAR interferometric SAR, it is also possible to detect ground deformation, so perfect when you need to monitor projects, such as, for example, underground construction. Our constellation is scalable because you have large range of resolution for different resolution from very high regional scale to down to very street precise level. We have also a long historical path because of all of our archive available, 2012 for optical, 2007 for archive. So you have all the history when you need to build a project, and also a huge flexibility thanks to rapid tasking and rapid delivery. So just to mention it and to details, I would like to cast a light on Pleiades Neo for that. 50 plans per satellite per day. We have also last minute weather forecast, so availing you to postpone, cancel your acquisition depending on the weather, and or also last minute tasking available. So every tasking plan are updated every 15 minutes. So at the North Pole, and you can submit a request up to 45 minutes after before acquisition. So very reactive when you need to act in a crisis event or something like this. So perfect transition to my next slide, which is the cycle of disaster management. In fact, it's always summed up as just the response during the crisis, the critical hours. But in fact, disaster management, it's a global cycle from prevention, the response, okay, the critical hours, and then the recovery and the adaptation to reconstruct better and in a sustainable way. So during prevention, our satellites could be used with some products to create models to make them available, for example, to scientists, to anticipate risk, to plan, to anticipate, to prevent any damages that could occur for the population. We could also detect early signs, such as, for example, vegetation stress, that could lead, for example, to the index for the risk for example, high or huge wildfires. During the response critical hours, our satellites, thanks to their flexibility and also the optical and the radar, we are able to support rescue forces to better act, to guide them during the response, to be sure that they could have the global overview of the damages and what is on the ground, to make the best decision at the moment. And last but not least, the recovery. Thanks to our archive, it's possible to have the historical past, to know what was in the past, what is the current situation, and then to prevent and to anticipate a better reconstruction and to build back better in a sustainable way. I will just mention things. Our constellation is used notably for the to support the Copernicus program, Copernicus Emergency Management Service. So we supply a lot of data for this typical crisis events to the communities, worldwide communities. So some example, this one is Worldem Neo example, so on a DTM. So it's in northeastern Germany, and it's a simulation of a dam break scenario, by the way. In the end of this scenario is, okay, thanks to this model, it has been possible for scientists to predict that in 16 hours after the break, the valley would be flooded. So then for the communities, availability to anticipate the risk, to maybe have a better rescue plan, etc., to make sure everything is correct. Another one is during, I'm pretty sure you will recognize it, it's Blatten Glacier in Switzerland. So in May, there were a huge rockfall, 6 million cubic meters of debris. So very huge. Here it's a Pleiades Neo image, and as you can see in one picture, you have a global overview of what's happening here. You can measure the different dimension, estimate the volume, etc. So very useful for that, and also to check early sign before maybe, or to assess the impact afterwards. So here it's, for example, the aerial view. So as you can see, with a satellite, you have quite similar view. Here it's a zoom, where you could see that the valley is totally recovered by debris. And unfortunately, people were evacuated before. And here, another example with the river that is blocked and the village that is flooded due to the debris. Another example, during the summer in France, maybe you were aware, there were huge wildfires, and we were able to supply with lots of data rescue forces to give them a global overview of the impact. So here, for example, it's a view where you can easily distinguish water bomber, for instance, but this one is more impressive because you have a large scale image, thanks to Spot, where you could detect and to check the impact of the biggest wildfire this summer in France, 18,000 hectares that were burned. So you can evaluate this and with, for example, historical data, check what was here, what could be also make it for the future. But I mentioned it at the beginning, our constellation do not only support governments, civilian rescue forces during crisis events. We also provide some products that are good for an appropriate and sustainable urban development. So, for example, with our stereo and 3-stereo acquisition mode, it is possible to derive models that could be used for urban planning, construction. We can give them to civil engineering companies, for instance, to make them assess the impact or the best approach to construct a bridge, for example, or to construct a district in a city. Directly linked to that, we have also digital twins. Thanks to this, we can also derive digital twins that are used by a lot of people now to prevent any risk in the city, anticipate construction, etc. And I encourage everyone to assist tomorrow my colleague Lea Kirbel, who will give a speech about this on this topic, especially. With ground monitoring, also with INSAR, it is possible to derive, I mentioned it, subsidence or uplift at a millimeter scale precision. So very good for monitoring underground project, for instance. Check if, for example, the tunnel is well constructed, if there is damages on the surface, also to prevent coastal tides, etc. So very appropriate for that. With our data and all the archive we have, it's possible to derive the historical analysis, temporal analysis, to know how is the city now, how it was in the past, how was also the land cover, the land use, how it has been urbanized, and what could be the risk for the future. So temporal analysis gives you the way to go from past to now and even to the future. And with data that are accurate, fresh, our decision makers, governments, local authorities, communities could make very good and evidence-based decisions to make the appropriate developments for the city, for the company, for everyone. So with our constellation, we are able to create a more sustainable way to anticipate the future and to support sustainable cities construction. I will just give you examples. So I mentioned it at the beginning, the INSAR. Here you have, for example, an example in Hungary during the construction of the underground. So you can see with the number of dots, the precision we could have for the scale. So you could see in green, it's okay. In red, there is subsidence, so with military precision, so very good for that. So all of our sensors could be used for planning before, having a global overview of the area. Then during also the analysis, to make sure that you plan everything correctly. So project planning, monitoring of what is happening on the ground, evaluate infrastructure, maybe infrastructure impact on the ground, and at the end, of course, the environmental impact of your project when you, for example, decided to expand the city in different manners. We can also supply very large overview. For example, here you have the example over San Francisco, where spot global layers give you a global overview of your region. So here, easy to distinguish the land cover, land use, how it is urbanized, where are, for example, green areas, etc. But I mentioned it at the beginning, very fine details also, thanks to HD15, where you could see very precisely small details, easy to distinguish when you need to plan, for example, urban growth, when you need to reconstruct a district or something like this. It's a perfect tool for urban decision makers. Another point, 3D textured model. Of course, thanks to stereo and 3D acquisition, we can also create 3D textured model, which is the foundation for all of all digital twin. Because with that, for example, over Cape Town, it's easy to modelize, to simulate what could be the impact of any project, any risk on the city, any, I would say, also prepare a sustainable growth of the city. So a perfect tool, and tomorrow you will have more details with my colleagues. So to end up quite this presentation, we have two different approach. Often natural disaster and urban development are treated as two different domains, but in reality this is two phases of a cycle, of the same resilience cycle, where we can supply with data. So when we provide data, for example, before any crisis, any damages, for rescue anticipation, to prepare plan, during also crisis events, but also after we can provide data to support the reconstruction, to have the build back before. Our unique differentiator are, I remind them, agility, because we have a large scale and wide range resolution, wide range also of sensors and data we can provide, with flexible tasking, rapid delivery. We also have precision, I mentioned it, 30 centimeter up to HD15, 1.5 meters for a large scale overview, but also radar for ground movements, so substrate level. Continuity with archive in our catalog, but also new tasking, new acquisition. And my last slide will be next generation sensors to come. A global trust from all of our partners, because we deliver lots of data for governments, for NGO, United Nations, but also the private sectors. We have plenty of customers using our data every day. And also intelligence, because we are not only delivering pixel, when it's needed, we can also deliver intelligent, actionable intelligence and decision-ready tools. So looking ahead, our next generation that is going to come. So in response to future cities and what is coming. We would like to introduce what we could do in the future. I would just start with Pleiades Neo next. We announced it a few months ago. So 20 centimeter class sensor. It will be the next generation for details, more revisits, more data to come. Also, other sensors in our constellation to guarantee our customers the continuity for the future. And our ambition is to remain at the forefront of the geospatial intelligence as a trusted partner for all governments, institutions, and also the private sectors. We would like also to derive not only the provision of data, but also to provide a global ecosystem. So you will hear this also for the main stage presentation on Thursday. So our constellation is a perfect tool for now, but will remain a perfect tool for tomorrow for supporting all government and institutions during their natural crisis response activities, but also to help urban planning, civil engineering companies to have sustainable cities in the future. So thank you very much for your attention. Vielen Dank für Ihre Aufmerksamkeit.